Hey guys, happy Thursday. We're going to do Thursday's DMR, and I think I put the DMR on your learning calendar for tomorrow. But if you finished it today, you don't have anything to do tomorrow as far as DMR. But Friday is a catch-up day, so if you're a day or two behind, just maybe you'll be playing this video tomorrow. So you have, again, some freedom with doing things at home, so I hope you're just working at your own pace. Please don't feel overwhelmed. I know I talked to a couple of you guys today on Miss Wilson's class, and it was so good to see your faces and hear your voices, and I'm thankful to be your teacher, and I just love you guys a lot. So let's jump into number one. It says, what are the prime factors of 24? So we are going to look for prime numbers, and we're going to look at the factors of 24. So remember, factors are two numbers that multiply together to give you a product. And the product we're going to focus on is 24. So every number has 1 times itself as factors, and then we will keep going to find other factors of 24. So for example, 2 times 12, 3 times 8, and 6 times 4. Can you think of any other factors that would make 24 that I may have missed? Let me know if I did miss any. And then we are going to look for the prime factors. So 1 is neither because it can only be made with the factor of 1, 1 times 1. 24 is obviously composite because it has quite a few factors. 2 is prime because it can be made with 1 times 2. 12 is composite because it can be made with 1 times 12, 2 times 6, and 4 times 3. So that's definitely more than 2. 3 is prime because it can only be made with 1 times 3. 8 is composite. It can be made with 1 times 8, 2 times 4. 6 is composite. It can be made with 1 times 6, 2 times 3. And then 4 is composite. It can be made with 1 times 4 and 2 times 2. So the only prime factors are 2 and 3. All right, perfect. All right, let's look at number 2 together. It says Joe received his paycheck for $82.60. And if he worked a total of 8.6 hours, how much did he make for 1? So what we need to do is we need to take his pay and we need to divide it across the amount that he has worked, which is 8.6 hours. And then that should tell me how much he's making per hour. Does that make sense? So Miss Connolly and Miss Wilson, we make a certain amount across a week, and then we can divide that out to figure out what our hourly pay is. So I'm going to use the calculator since this is a word problem. So Joe is making $82.60. I think my calculator just cracked out on me. I can show you how to do it while my calculator is coming back up. I'll show you how to do it without a calculator. All right, let's see what we can get done here. Okay, perfect. All right. So if you were to do this without a calculator, I'm going to get some space. The first thing I want you to notice is that there's a decimal inside the house and there's a decimal on the outside. So normally when we divide with decimals, we put the decimal straight up. But if there is a decimal on the outside, we need to multiply it by 10 so that the decimal moves over and we'll get 86. And then we're going to do the same thing on the inside. Kind of like a fraction, when you change the numerator, you also change the denominator. So if I'm moving a decimal by multiplying by 10 here, I have to do the same thing here. So then the product of moving the decimal becomes, okay, see how the decimal moved over? Now, if you don't believe me and you don't trust me, you're more than welcome to put $82.60 in your calculator and multiply by 10. You'll see that the decimal shifts to the right. Okay, and then you can use your strategy of moving the decimal straight up into the answer, and then you would divide using multiples of 86. Now, this is where it gets a little tricky because 86 cannot go into 8. And then 86 can also not go into 2, or 82, excuse me. Because 86 is larger, and then you would need to figure out how many times 86 goes into 826. And again, I'm just going to wait for my calculator to load. I really don't think it's fair for me to expect you to know your factors of, your multiples of 86. So what you would do is you would list down the side, 86 times 1, 86 times 2, and then you would have to figure out how many times can 86 be divided by 826? Does that make sense? I know that is definitely new for us. We kind of dabbled in what happens when we have a decimal on the outside, but we didn't really go into a lot of direct instruction with that. So again, if you want to try it in your calculator, multiplying something by 10, a decimal by 10 will move the decimal to the right. And if you divide by 10, it will move the decimal to the left, and it will make your value smaller. So my calculator's back up. So $82.60. $82.60. And then Joe's working 8.6 hours. So he makes about, I'm going to round it, about $9.60 an hour. When you type it into your calculator, you're going to get 9.604. I'm going to round it off to the hundredths place, because when you make an hourly pay, and you'll know when you get a job, they will tell you like $10.25. So they always stop it at the hundredths place. Okay. All right. Let's move on to the rounding. So number 3 is one of those backward rounding, where we need to figure out which of those 6 numbers would round up to 78. Okay, so our goal number is 78. So let's say I have the number 77 and 382 thousandths. So I'm going to look at this whole number 77, and I'm going to look next door. The 3 is either going to keep the 77 a 77, or it's going to round up and match our goal number of 78. So remember our rule: if it's 5 or more, you're going to raise the score. But if it's 4 or less, you're going to leave it. You're going to let it rest. So the 3 is next door, so that lets me know, let's say I have $77.38. I'm going to be closer to $77. So that's not going to meet our goal number. You can also use the number line strategy to try to plot that, and you'll see. Okay, I'm just going to go straight across. So if I have $78 and about 10 cents, that's going to stay close to $78. Okay, and then I have $77 and about 69 cents. So if I look next door, I have that 6, 5 or more. We're going to raise the score, so it's going to bump up to 78, and that meets our goal number. Okay, so let's say I have 78 and let's say about 9 cents. Well, of course, if I look next door and I have a 0, it's definitely going to meet the goal number. Okay, let's say I have $78 and about 80 cents. Well, if I have 80 cents, I'm getting close to the next dollar, so this would round up to 79. And again, remember our goal number was 78, so this one won't match. I hope you're thinking about this logically. A lot of times we get used to, 5 or more, raise the score, but we don't really understand the concept behind it. So if you think about it like money, if I have $77.06, right? Let's just ignore the thousandths place. Would you say to someone, oh, I have $77, or would you say I have $78? Well, if I have $77.06 in my wallet, I would tell someone I had $77 because that's what I'm closer to. And we are not closer to 78. So when you're rounding, you're really finding what number you are closest to on a number line. So if we were to plot, say we have 77, we have 78, we have $77.50. Let's say we were to plot $77.06, right? It would probably go right here. Whereas let's say $77.95 might go over here. Do you see what I mean? So when we're rounding, we're finding what am I closest to? So that makes sense that I'm closer to 77, which doesn't match what we wanted it to round to. So I hope that makes sense for you guys. All right, let's move over to number 4. Okay, I'm trying to zoom in a little bit. Number 4 says Pete has 4,000, don't mind my cat, 326 marbles, and he gives some away. So he gives away 3,936 of them. And then he wants to split the remaining amount between 12 of his friends. How many marbles does he have now? So this lets me know I've got to do some steps before I find out how much he has right now. So he started with an amount and then he gave some away. So this is similar to the number 4 yesterday. If I'm giving something away, I can assume that I'm going to have less than I started with. So 6 minus 6 is 0. I can't take away 3 from 2, so I'm going to borrow a group. Okay, 2 becomes 12. So 12 take away 3 is 9. Okay, now I'm going to look at this. I'm not going to regroup. I want to show you this. Don't regroup. Don't go over to the 4 and borrow. Let's think about it logically. 42 take away 39. You can use a counting up strategy. So I would start at 39 and then I would go 40, 41, 42. How far away am I? I'm 3 away. 39 is 3 away from 42. So I hope you see what I did there versus borrowing a group from the 4 and making the 2 at 12. Okay, so we're going to pause right here. This is how many he has after he gave some away. Now, I've always told you this. If you were doing a multiple choice quiz or something, you know your first step is going to be an answer choice. I see it right now. There it is. 390. But if you think about the problem logically, it says, and then he splits the remaining amount with 12 of his friends. So this goes back to your reading skills of sequencing. He does something and then he does something next. So when we're splitting something, I hope that triggered the operation of division in your brain. So he's going to split the 390 with 12 of his friends. And it says it in the problem, 12 of his friends. So this is a word problem. I'm okay if you want to use a calculator. I'm going to check it on mine and then we'll see. Okay. If you do it on the calculator, you're going to get a decimal as a leftover. So a decimal is not a choice as a leftover. So that means we're going to just have to do it out, which is no big deal. So let's do our traditional way. So can 12 go into 3? No. Can 12 go into 39? Yes. How many times? So on your calculator, I'm okay if you're doing, okay, 12 times 2 is 24. So I'm listing my multiples. 12 times 3 is 36. 12 times 4 is 48. And I'm going to stop right there because my goal number is 39. So I'm going to choose 12 times 3 is 36. Then I'm going to subtract 39, take away 36. I'm going to count up 36, 37, 38, 39. I'm 3 away. Then I'm going to bring down my 0. Okay. Now, 12 can go into 30 how many times? Well, if I choose 3 again, I'll be over the amount that I need. So I'm going to choose the multiple of 2. So 12 times 2 is 24. and 30 take away 24. Again, don't borrow. Count up with your fingers. So 24, 25, 26, 27, 28, 29, 30. I'm 6 away. Okay, so if you do it on the calculator, if you do 390 divided by 12, you're going to get 32.5. I will tell you that the decimal tells me that I have a remainder, but it doesn't tell me how much the remainder is. Okay, it tells me I have 32 and a half. So in order to interpret that, you have to do the long division. So the long division tells me that each friend is going to get 32 marbles, and then Pete is going to have 6 marbles left over. So there's my answer choice. Now I'm going to go advanced on you for a second because I think you can handle it. So let's look at this answer choice for a second. 32 and a half, or 32 and a half was what I got when I typed it on the calculator. Because when I was dividing marbles out, I was dividing them among 12 friends. Okay? So each friend gets 32 marbles and a half is left over. Here is where the half comes from. If I'm dividing it with 12 friends, what's half of 12? If you said 6, that's why your answer is 6. Ooh, that's good. So you might be able to understand when you divide and on your calculator and get a decimal. If I get a half, well, I need to figure out what is half of my divisor. Well, half of 12 is 6, so my remainder is 6. It's not always that easy because sometimes when you divide, you don't get 0.5. Sometimes you get 0.37621, and that is almost impossible to interpret. So I hope that made sense. All right. Let's look at number 5. So number 5 is the school bought 9 pizzas for lunch. The teachers ate 1/3 of each pizza. How much pizza did the teachers eat? So that means that 1/3 of each pizza is going to go away, and then we're going to count how much that is. And then I will tell you that normally each, I don't always like keywords, but most of the time each can be division at times, but in this scenario it means that we are going to find a product. So like each of you are going to get an amount. What is the total amount? We're going to have to multiply. So let's just do the picture first. So each teacher eats 1/3 of the pizza. So I'm going to shade in 1/3 of each pizza. 1, 2, 3, 4, 5, 6, 7, 8, 9, because there was 9 pizzas. And then I'm going to move some pieces around, okay? So shade in your 1/3 of each pizza, and then follow me with moving it around. So I want to know how much pizza did they eat. And to make it easier on myself, I'd like to make whole pizzas. So I'm going to take this 1/3, and I'm going to combine it over here. See what I did? I'm going to take this 1/3, and I'm going to make that whole pizza, okay? I'm going to take this 1/3, move it over here. I'm going to go a little bit faster. So looking at my picture, they ate 3 whole pizzas. All right, let me show you the math. So there's 9 pizzas, and they ate 1/3 of each. Okay. Remember, you can write 9 over 1 because it's 9 wholes, 1 being a whole, so 9 wholes. And then when you multiply fractions, you just multiply straight across. 9 times 1 is 9. 1 times 3 is 3. Now here we have an improper fraction. An improper fraction can be written as a mixed number. Don't be scared. The fraction bar just means division. So let's do basic division together. 9 divided by 3. If we were in the classrooms, I would make you put your arms up. 9 divided by 3. We've done this. And 9 divided by 3 is 3. So they ate 3 whole pizzas. And that matches our picture. Great job. I love you. I miss you. I'll see you tomorrow, okay?